Let's look at the refractive index of a glass prism using a spectrometer. So with this experiment, we are interested in finding a refractive index of the material of the prism, the refractive index of the material of the prism, and then also the least count of the spectrometer. Okay, so that's what we are interested in finding. Now, straight to the diagram, you can use the diagram to explain this and then how this formula came about. So this is the formula that we'll be using to find the refractive index. So we'll be looking at how this formula came about. The video don't have to be too long, so if you don't understand anything, you try and then pause it and then try and then get it before you move on with the video. Okay, now this is the diagram. So that's the glass prism. Okay, this is the telescope. Okay, this is the telescope. This is the collimator, so we call this collimator. Okay, and then this is the spectrometer, so that's the spectrometer. This is our sodium light, and then the sodium light, the power. Okay, so that's it. So we are trying to see the angles for this particular prism. So per the diagram that we have here, as I said, the video don't have to be too long. Okay, this is just a practical. Okay, we realize that this angle is equal to this angle. I mean, this line and this line, this is the same as this line is the same as this, right? Which makes this angle I equal to the whole of the angle here. Not only R, not only this, the whole of the angle here. And the same thing applies for this side, right? So it means that if we want to get this I, the value of this I, we can add 2 of this to get this. That's the meaning. The same thing for the other side. If you want to get R prime, we can add 2 R prime to get I prime. If we want I prime, we can add 2 of this. Meaning that if we want one value of this, we can divide this by 2 and then we get one value of this. The same applies here. Or if we have this value, right, and we have this value, we can subtract this from this to get this particular angle. Okay, so that's the meaning. Everything here, when you study it very well, you understand it. Okay, now let's go to some of the applications. Now you see, when you have I minus R, so D here, right, D here, realize that if this line is parallel to this line, it means this angle here is the same as this angle here. Okay, so D here, D minus I minus R into brackets plus I prime minus R prime should give us this. We can call that one equation 1. Now, since the quadrilateral AQNR is a cycle, right, when we do our factorization, we'll come and arrive at this equation. So this is the angle A, right? We are interested in finding the angle, okay, that angle A. Okay, now moving on, so after some simplification, we can have this equation and we call this one as equation 2. Okay, now after that we can see that, for example, if R equals to R prime, right, let's come back here. We have to, if you study this one very well, you understand that this, you see, this angle here is the same as this angle here. So that's, if R equals to R prime, then I is also equals to I prime. Okay, which makes this equation 1 and 2 will become this. Okay, so after further simplification, we can find I from this, right? And then we can also find R from this. Okay, now here in your books you see A times 2. It's not A times 2, it should be A on 2, right? A divided by 2. So now substituting this expression for I and then this expression for R into this particular equation, you see, we put, wherever we see I here, we put this. Wherever we see R, we put A on 2. We'll get this expression, which will help us to find the refractive index of prism using a spectrometer. Okay, now this is the diagram of the spectrometer, right? The sodium lights, collimator, and the telescope, and then the spectrometer. So we'll be performing this experiment in 2 ways. Okay, first we have to find the deviation, right? The minimum deviation. So the D. You see, we are interested in, these are all constants, right? So we are interested in finding this, which is the same as this, and then this, the angle, and then the deviation. Then we can substitute it here, and then we can find the refractive index. So that's what we are interested in. And they are saying that in doing that, first of all, we can turn this in 2 ways. Okay, we can turn this in 2 ways. Now, coming back to the diagram. Realize that this prism, our prism, it has 2 transparent sides. So this side is transparent, this other side is also transparent. But this side is blurred, if you can see. This also another example. This side is blurred, this side is transparent, and this side is transparent. Okay, so that's the thing. So to do that, this particular diagram, or to find the deviation, right, we'll be using this table. Okay, first we can do for the angle, and then second we do for the deviation. Okay, the angle and deviation. Okay, so let's do the angle first, because that table is first. Now this column is talking about the angle. Okay, this column is the angle, and then this column is the telescope reading to the left. We can call this column telescope reading to the right. Then here will be this on this divided by 2. Whatever is here, the same thing that's here. Okay, the same thing for this side as well. Telescope reading to the left, telescope reading to the right. Okay, and then we have this particular side. So for the angle, now checking the diagram, realize that this is how the telescope is, the prism is shaped, right? So this is how we are supposed to place it, this way. We place the blurred side. Okay, this is the 2 transparent sides. So this, the transparent side, this is also transparent, but this side is blurred. So that's how we position it. So this is supposed to be our collimator. Okay, so our collimator, so where our collimator is facing, we place this like this. You get it? We place it like this, so that the back side, okay, will be facing, the blurred side will be facing where the telescope is. Now when you look through the telescope, right, you should be able to see our 0 point, or our 0 order. We call it 0 order. You see a line, the sodium light has drawn a line through the telescope. It's unfortunate that we can't see through the telescope. Okay, so let's just move on. So we'll see our first order. We'll see a line like this. We'll see a line like this, right? We'll see a line like this. Okay, so we'll move to the left, right? We are doing for the left first. So after finding our 0 order, we move to the left. We are on the first one. We move to the left. We keep moving like this. Okay, we keep moving. We find another line, or the left order. You see, we find another line, and then we record that one on the spectrometer. and then we come back to our zero order. We come back to our zero order. We keep moving this. We move this to the right side, and then we find our right order. Okay, then we record that one here. So left and right. Now you can add this and this and find average. Now for this and this is repetition, right? So if you are performing this experiment alone, right, you can just do it again. So you start again, then to the left, and then to the right. Then for the third time, you start again to the left, and then to the right, right? When you are moving to the right, make sure you set it at the zeroth order first. Okay, make sure you see the zero order so that when you are moving here, you can be able to see the right order. Now the principle behind this is that the two transparent side here will reflect the light coming from here. It will throw them away. It will reflect the light coming through this prism. Then on this telescope, we'll be able to see the line. So that's the principle behind that. So that's how we do this. You move to the left till you find the left order. You move to the right, you find the right order, then you can find the average, right? The left order minus the right order divided by 2. So we repeat that thing for the second, we repeat it again and then again for the third time. Then we are done with this. Now for the deviation, when we come back to this diagram, the deviation is saying that we should place this telescope this way, this prism this way, right? This is how we place the prism for the deviation. We will let the transparent side, right, face this side. If we are going to the right, left, we will let the transparent side face the left side, the blurred side. So this is the blurred side. So you check, this is the blurred side, this is the transparent side, this is the transparent side. So we will let this blurred side face the left since we are going left, right? We'll be going left first. So when the light comes through the collimator, the sodium light, we go to the left, then we see it will go through the transparent side, right? Then we can see it on the left, and then when we move far to the other end, we should be able to see it through this edge here, right? When we move to the right. Okay, so we place it this way. Then we move to this side. Okay, we move to the left side. Okay, then we place it again, we come back, we move to the right. Okay, so it's just one position. As I'm saying, when we are moving to the left, we make sure we let the transparent side face this way. So we move to this side. When then we are moving to this side, we turn it. We make the transparent side face this way, and then we move to this side, the right side. Okay. So when you're moving this way, you let the transparent side face here, and then the blurred side face the other side. Then we move this side. That's for one, right? So when it faces this way, right? When it faces this way, we'll be moving to the right, right? Then when it faces this way, we'll be moving to the left, okay? Then we record. So one will be for the left. So the left, to get this first value, we turn it this way. And then when we are moving to the other side, we turn it this way. Then record that one here. Okay. Then here will just be this minus this divided by 2. We repeat that one again. So we repeat the procedure for 2 more values of left and then right. Then we can fill the table. So that's how we fill the table. Okay. After that, since we repeated these values here, okay, so what we do is that we can find the average of all these individual values, the same thing here, and then we call that one A. Then we find the average of all these values again, and we call that one D. Now we come and insert them in this equation. So we need to calculate this. So this, we can even say this is A, right? And then we can also say this is D. But after that, we have to add all this again and then find the average. And then we call that one A, just A. Then we add all these values here, right? You see this minus this on divided by 2, write it here. This minus this divided by 2, write it here. So we do for all this. Now after that, we add all these values and then we find the average and then we use that one as D. So in using that as D, we can come and put or insert it in this equation to find the refractive index using the spectrometer. Okay. Now, for the calibration of the spectrometer, now we can see that the spectrometer has 360 degrees. Okay, 360 degrees. So this is 340, 350, 360, then 0 starts from here, 10, 20 in that order. Okay, now if this is in 360 degrees and then 1, right, 10 degrees, right, has 10 divisions. 10 degrees have 10 divisions, okay, meaning that each division there is 1 degree. So each division is 1 degree. Now this instrument has a main scale and then the vernier scale. Okay, this is the main scale and then this is the vernier scale. Now each division here is 1 degree, meaning that the vernier scale, which is here, this is the vernier scale. The least count that is here is what has been expanded to be this. So the least count that is here is what has expanded to this, right? So this is actually supposed to be 0 to 1, 0 to 1, okay, 0 to 1, okay. So the expansion of the least count of the main scale will give us the vernier scale. So that's how we get the vernier scale. Now, before we start the experiment, right, before you start like this, we have to set this to 0, right? So to set this to 0, we have to let the 0th mark, this particular 0 coincide with the 0 on the vernier scale. So we can just move this like this. Now you can see that the 0th mark, now you can see that, pardon me if my camera is, you can see that the 0th mark has coincided with the 0th mark on the vernier scale. So when we move this to the right, the reading we have here, right, we check where the 0 is. So this is on 310. Okay, so this particular one will give us 313. Okay, 313 on the main scale. Now we can come and read the vernier scale as well and then add it to the value we have here, 313. Okay, so to read the vernier scale, the value here, pardon me if you can't see the divisions here. Okay, to read the values that we have on the vernier scale, we can check the line here that best coincides with the line, a division here, right, that best coincides with the division on the vernier scale. So in checking this, I can see the 3 is still the one that best coincides with the 0th mark here. Okay, the 3. Yes, it's the 3. Okay, so we can say that this value, this particular reading, is 313.3. To the right is also the same, right? To the right is also the same. Now to read this is on 50. So the 0 mark is on 51. Okay, so 51. So that's the main scale. We're having 51, and then for the vernier scale, we check the line that best coincides. So we can say that we have 51.1, okay, degrees. So that's how we read the spectrometer. Okay, we apply this same way of reading the spectrometer in doing this particular experiment. Okay, in doing this experiment. So see you there.